Okay, this is the last question, 4.4. We're going to prove that this BR times RQ is equal to RS times RP. RS times RP. Well, I looked at this thing and I went, okay, there's BR, and I put a little green line on it. And then I went, okay, RP, all the way from R to P. Well, then I put a red line on it. And then I went RQ all the way down there, that red line. And then I'm thinking, well, this triangle goes with OR. But it says I want RS. Well, there's RS sitting over there. If I could prove RS is the same as OR, I could use this triangle here. And if I could somehow prove that that was parallel, then I could use the proportionality theorem. Now, you know what? There's many ways sometimes to answer these questions. You can use different reasons. You can use similarity, and if you look at the memo, that they use similarity to figure this out. I like the way I did it, and I use proportionality. So let's just see if we can get started and do what I'm doing here. I saw these letters, and I'm going to go for proportionality. Now, I know that P2 is 90 degrees, and now I'm looking over here at B2 being 90 degrees, and that looks kind of like a Z to me, and that forces the line PQ and BO to be parallel. So I can say that PQ is parallel to BO because the alternate angles P2 and B2 are both equal to 90 degrees. So that's what I would do first. I'd establish that they're parallel. Now that I've established that they're parallel, I can use the proportionality theorem. I can say that BR over BR over PR equals OR over RQ. And you know what? If I cross multiply, there's the BR/RQ. I've got the PR or RP here. I just have to prove now that OR is the same as RS, and I'll be done. So I'm looking at these two triangles here, and I've already proven that R1 and R2 is equal to X. Angles in a line, if that's 90 degrees, it's got to be 90 degrees on the other side. And these two triangles share a common side. That means that they must be congruent because of angle, side, angle. Remember that from grade 9 in congruent triangles? Well, I'm going to use it again. I'm going to prove that RS equals RO. And I've just done it, actually. I've said that, and I would lay it out like this. I'd say in triangle SBR and OBR, I'd say that B2 and B3 are equal to 90 degrees. I call that B3 equal to 90 degrees, maybe even say angles in a straight line. Then I'd say those triangles share the common side BR, and that they have an angle that's the same R1 and R2. And because it's already, we had already proven that. And now I can say that these two triangles are congruent. Therefore, SR equals OR. Well, if SR equals OR, then I can replace OR with RS or SR, RS. Then when I cross multiply, I get what I've proven. Now, I've done quite a few different things in all of the things I've been talking about there. Let me just go over it quickly again. I proved that these two lines were parallel because of P2 and B1 being alternate angles of 90 degrees. Then I used the parallel lines in the triangle PQR and OBQ, that those two little triangles there, but that triangle that has a parallel line going across it, I can use the proportionality theorem to say BR over PR equals OR over RQ. Then if I cross multiply, I almost have my answer, and I've only done about 3 marks worth of work. But now I've got to prove that this RS is equal to OR. And I did that with angle, side, angle. A shared common side, angle, these two angles being 90 degrees, and these two angles being equal, already proven. And once that RS is equal to OR, I just put it in there. I put in RS in there, I cross multiply, and I get my answer. And there you go.